Welcome to Honors Geometry, Lesson 5.6, the Hinge Theorem. This will be the last section in Chapter 5 that we do. And let's get at this Hinge Theorem. And you want to talk about words? Words, words, words. I'll let you go ahead and write it down. You pause it, and then you can start it back up after you're done. And we'll look at an example or two. Actually, just one example. And then we'll talk about the Hinge Theorem Converse. Alright, here it comes, the Hinge Theorem. Go ahead and write that down, memorize it, and when you're done memorizing it, then you can hit the play button again. Now, I hope you didn't actually memorize it, but did read it a couple times, and I really doubt that it made any sense to you. But when I show you the example, it'll make a lot of sense, and the name of it will make a lot of sense too. Alright, let's look at an example. Alright, what we have here are two triangles. Two sides of one triangle are congruent to two sides of another triangle because of the single tick marks and the double tick marks. Now, it's like a door on a hinge. Okay? See, this door is opened a little bit, and this door is open less because it's a smaller angle, with these two sides being the same. So we can actually make a conclusion here. We can say that segment MN is going to be larger than segment RS. Sorry, the length RS. Because this door has been opened more on this hinge right here. So that's why it's called the Hinge Theorem. Alright, let's go ahead and look at the Hinge Theorem Converse. I'll let you go ahead and write that down and have some fun with it. Don't try to memorize it this time. That was mean of me. Of course, what else am I other than mean? Alright, go ahead, pause, and write it down, and I'll get right back with you. Alright, you got that down? Good. Now let's go ahead and look at the Hinge Theorem Converse. Once again, we have two sides of one congruent to two sides of another, and this time this side right here is less than this side. The third side, one's bigger than the other. Okay, that means that this door has been opened more. This door right here has been opened up more than this one right here because the opening is less. So our great big conclusion is nothing other than the measure of angle A is greater than the measure of angle B. And that's all that the Hinge Theorem and its converse has to offer. Lots of words for little bitty payoff. With the Hinge Theorem, we can conclude that one side is greater than another by looking at angles. The Hinge Theorem Converse, we can make a conclusion about angles by looking at the third sides. This will conclude Lesson 5.6, Honors Geometry, the Hinge Theorem.